Hello there, I'm Sam with JBugs.com. In our last few videos, we pulled apart the engine from our 1971 Super Beetle as it wouldn't turn over. We discovered a drop valve, a hole in a piston, and excessive crank end play, which meant the engine needed to be fully rebuilt. We were hoping that the bottom end was in better shape, as we were planning on a set of thick wall 88mm pistons and cylinders, along with big valve heads and installing some high ratio rockers. This would have increased the factory displacement from 1600, which is actually 1585 cc's, by 94 to 1679 cc's. More importantly, none of this would have required splitting the engine case. That opportunity is gone, and while we'll still be using the same bolt-on top-end parts we had originally intended, we're going to be building an 1800 cc engine by adding a 74mm crank to the mix. The intent of this rebuild will be to keep special machine work to a minimum, and while we did have to head to a machine shop to have our case line bored, like anyone that's rebuilding an engine would have to, that was it. Everything else for the rebuild can be done with common tools most of you would have at home in your garage, and a few inexpensive specialized tools here and there. This isn't a high-performance race build though, and all the steps of our engine build can be done by the average person. We aren't weighing every part, spin balancing every component, or blueprinting the case. This will be a simple garage build. We start by cleaning the crankshaft thoroughly, and so we don't have to mention it over and over again, every part that we will be working with is cleaned completely with parts cleaner and blown off before it's test fit or assembled. Our engine case is clean, and all the patches have been flushed and blown out. Oftentimes, the same part is cleaned 3 or 4 times in between test fitting and final assembly. We start at the bench with our crankshaft, which has been 8-doweled, with an offset pin, and we're matching it up to a lightened 8-dowel flywheel. Then the crank is set upright onto it to make assembling the rest of the components easier. We start with the number 3 bearing and coat it, and the crank with assembly lube, and slide the bearing onto the crank journal. Make sure the dowel pin hole is offset towards the flywheel so the bearing will align properly in the engine case later. The timing gear keyway is set into place onto the crank. Then we'll prep for installing the cam and distributor drive gears, which will not fit onto the crank unless they're heated up or pressed on. As we don't have a press here, and most of you don't have one at home either, we'll move outside for safety and fire up a propane grill. The cam drive gear and distributor drive gear are set into a pot of vegetable oil and placed on the grill. It takes some time, but eventually the oil, and most importantly the gears, get hot enough. More or less, once the oil itself starts to smoking steadily, we're ready to install the gears. The timing gear is pulled from the oil with a set of tongs, and grabbed with a welding glove covered hand, and set onto the crankshaft, making sure that the timing marks are pointing towards the crank pulley side. The gear slides down freely and actually knocks the keyway loose. Some quick hands are needed along with a punch and hammer, which are used to straighten the keyway and then tap the gear down completely. Next, a full circle gear spacer is installed on top of the timing gear, and it's followed by the heated up distributor drive gear. The grill is turned off, and we'll move back inside to continue our build. Back on our workbench, the timing gear snap ring is slid onto place with a pair of snap ring pliers and tapped into place into the groove onto the crankshaft. Next for the rods, and seeing as stock rods won't last long after 5,000 RPM, and our new engine build will easily turn past that mark, we'll install a set of stock length chromoly I-beam connecting rods. New standard rod bearings are installed, and note that our connecting rods don't have a raised nub like the stock rods to indicate the top. We instead look at the stamped numbers on the rod ends, which will align the top sides, and the bearing tangs, which will sit at the bottom. The bearing and the rod journals on the crank are covered with assembly lube. The rods are set in place, making sure the rods, and most importantly the top numbers, are aligned and facing up. In our case, seeing as we're using a stroker crank, we'll be checking clearances, so we won't be using thread locker on the threads of our rods yet. The rod bolts are coated with assembly lube, and then torqued sequentially to 15, 20, 30, and finally 38 foot-pounds. Those specs are specific to our aftermarket rods. Stock connecting rods would be tightened to 15, 20, and 24 foot-pounds. With the connecting rods tight, we check that they rotate freely on the crank, and rotate them to check the alignment with the stamp numbers all facing the same side. Starting at the flywheel side, the rods are in order: number 3, number 1, number 4, and number 2. Next, the front bearing is coated with assembly lube and slid onto the crank. Again, make sure that the dowel pin hole is offset towards the flywheel. That's followed by the oil slinger, which is disced and set in place with the dish pointing towards the crank pulley. The crank pulley keyway is tapped into place, and we check the fit of a stock crank pulley, making sure it fits over the keyway. Next, we mount the left side of our freshly machined and cleaned engine case to our engine stand. We install the 4 main bearing dowel pins and set the number 2 half-circle crank bearing into the case and coat it with assembly lube. We also test fit the rear number 1 bearing, which is cut down by our machine shop to match the cut down thrust surface on the case, and mark the bearing so lining it up later will be easier. Since we have a stroker crank, we need to check for crank and rod clearance to the engine case, so we're only going to be doing a test fitment. If you're using a stock crank, this next process isn't necessary. The crank assembly is pulled off the flywheel and the number 1 bearing is lubed and slid onto the lubed crank at the rear, making sure again that the dowel pin is offset towards the flywheel. The crank is lightly set into the case while holding the number 1 and number 2 connecting rods up. With the crank in place, the 3 full circle bearings are rotated until they align with the dowel pins in the case. We start with the number 1 bearing, then the front bearings are aligned. With the bearings all lined up with the dowel pins, the crank will settle fully into the case. Spin the crank over by hand to verify the bearings are set in place. The bearings should not spin, and an additional check would be to set the remaining center half circle bearing onto the case at the number 2 journal and check for a gap by trying to push the bearing towards either side. If the bearing moves, there's a gap and the other bearings are not lined up properly. With the bearing alignment confirmed, the bearings are marked at the sides of the case, so lining them up again the next time will be easier. Back at our bench, the right side case half is prepped by inserting the alignment dowel, and the remaining center half circle journal bearing is set in place into the case and coated with assembly lube. The right case half is brought over to the stand and set in place onto the left case half while keeping the number 1 and 2 rods upright to clear the case. Washers and nuts are set onto the main studs and snugged down lightly. Now we can rotate the crank and check to see if the crankshaft or connecting rods hit the case. For the most part, the rod's clear, but at the outside of the stroke, our rod bolts hit the inside of the engine case. The interference is minimal and only at certain angles, but the bolt heads or the case must be clearanced to ensure that 2 will not hit. At this point, either the case or the rod bolts will be clearanced. The rod bolts are the simplest to clearance and won't require another thorough cleaning of the engine case, so we mark all 8 of the rod bolt heads to indicate where the material will be ground away. Note that the next torque sequence will most likely line the bolt heads up a few degrees clockwise past this point that the bolt heads sit at now, so that will be taken into account when we grind the bolt heads down. The nuts and washers are removed from the main studs, and the right side case half is pulled off, set aside and covered. The crank assembly is lifted from the left case half, set on our flywheel, and the left case half is covered. All the connecting rod bolt assemblies are removed, the crank assembly is bagged, and then the bolt heads are ground down at an angle so they won't hit inside the case. We still leave a bit of material for our 12-point socket. With all of the bolts clearanced, they are cleaned, recoated with assembly lube at the heads, and the drop of blue thread locker is applied to the threads before the bolt is threaded back down into the rod and tightened down in sequence again to 15, 20, 30, and 38 foot-pounds. Stock rod nuts will be tightened to 15, 20, and 24 foot-pounds, and then either peened over after being torqued, or if the rods do not have a notch for peening, thread locker would be used on the nuts. We test fit the crank assembly into the engine case to make sure the clearancing is sufficient, and with the rod clearance confirmed, we pull the crank and bag it for safekeeping until our next video. There, we'll get back to the engine case that is sitting on the stand, and we'll install all the engine internals, drop the crank back in, set the opposite case half in place, and get the short blocks torqued down. This will obviously be a multi-part series, and while some of the steps are specific to our mild performance build, these same processes would be used on a stock 1600 build. If you're looking for something to keep you busy until the next video is released, head over to JBugs.com for all of your vintage Volkswagen parts and accessories.